Okay, everyone. So today we're going to be looking at combination circuit analysis. So this is where you're going to have a combination of things that are like, loads that are in series with each other and also ones that are in parallel. So basically, we already know the relationships, right? We're essentially going to analyze and look at different examples of circuits. So just a quick recap. You should know this by now. Okay, for a series circuit, right, we have one path. The current is all the same, right? They're all the same. Your voltage is additive, and your resistance is additive, pardon me. Where you have parallel, right, that means you have more than one path. Your current is additive. Your voltage is equal, and your resistance is a relationship known as Kirchhoff's law. Okay, so let's just start taking a look. So the best way to approach these is you first have to realize what is in parallel, what is in series. And the goal is really to combine different sections so you can eliminate information and get it down to be a series equivalent. Okay, so what do I mean by that? So right now we have our source, right? So it's like our total. And we have resistance at different locations, right? So we have 1, 2, 3, and 4. So first let's discuss. 1 and 4 are in series. Okay, so actually, let's do pathways that are happening here. So one pathway is this green line, right? Another pathway is this red line. Okay, so R2 and R3 are parallel to one another. This line and this line. But technically, R1 and R4 are series with each other. So what we would want to do here is we're going to figure out what this section of the circuit is all about. And then once we understand this, we're going to get the equivalent of them together. Okay, so this will make more sense once we kind of get into this here. So let's go over what we know, what we're looking for. Okay, so we have R1 and R4 in series, and we know that these two are in parallel. So right now we have the voltage. We have no information about current, zero information about current. Vs, we have that it is 100. We have no information about the rest. And we have information here, right? So we have 100 ohms, we have 1500 ohms, we have, this should be a 3. This is 1500 ohms. And this should be, oh my goodness, what did I do with the resistance? This should be R4, which is 150 ohms. Okay? All right, so what we're going to do is we first have to solve for the RS, okay, because once we have RS, remember that anytime you have 2 out of the 3 pieces of information, we can solve for the third one. So once we have RS, we can solve for IS. So you're probably wondering, well, why can't we do these voltages? Okay, but it's not as easy as you would think, because remember, 2 and 3 are parallel. So what that means is these two numbers will be the same, but 1 and 4 and this number have to add up to 100 volts. Okay, so let's take a look. So first, let's actually, you know what I'm going to do? I'm going to take this picture and we're going to continue this on another, on a new page. Okay. So our goal right now, what I'd like us to solve for first is RS. Okay. So RS is really going to be right over here. That's what we're trying to solve for. So the first thing we're going to do is we have to figure out what is our 2 and 3. Because 2 and 3 are in parallel with one another. And we have to figure out what these two are together so that we can then do a simple series circuit here. Okay, so R2 and 3 is in parallel, so we're going to follow our parallel relationship. So 1 over R2 and 3, and I'm going to use this because we're trying to find the total of this parallel section, is going to be equal to 1 over R2 plus 1 over R3. And it should look familiar. So this is going to be 1 over 1500 plus 1 over 1500. So actually, this is already lowest common multiple, but honestly, it's easier just following the way that we've been doing things. So we're going to do 1 divided by 1500 plus 1 divided by 1500 plus 1 divided by 1500, which will give us 0.00133, and that's continuous. Okay, we're going to flip these. So 1 over 0.001333 is equal to R2 and 3. So this is 750 ohms. Okay, so we figured out that this entire block is 750 ohms. So now that we know this, we're going to now consider this to be this entire section. So when we do this loop, we can now use our series rule because it's going to be R1 plus R23 plus R4. So RS is going to be equal to R1 plus R2 plus 3 plus R4 because we now know what this is equivalent to. Right? So we'll go back to the original picture. So it's like we're going this way, and we figured out what this section is together. So now we can consider this to be a series equivalent. So it's going to be 100 plus 750 plus, what was that last one? 150. Okay, so which gives us 1,000 ohms. Okay, so this guy here is 1,000 ohms. So now life's going to start getting a little bit easier now that we've solved for that. Okay, because we'll have some more information. So we're going to use Ohm's law to solve for IS. So remember, V is equal to I times R. I is equal to V over R. So it's going to be 100 divided by 1,000, which is 0.1 amps. Okay, so 0.1 amps. So that means, let's take a look at what is in series. So 1 and 4 are in series, correct? So that means my 1 is going to be the same, and my 4 is going to be the same. Because remember, they haven't split yet. So this and this are in series. So they're going to be exactly the same value. So now here, I1 and I3, we're missing that information still. But so let's hold off on that for a second, okay? Because we don't know if they're going to be exactly the same or if they're going to be different, okay? So we're kind of just going with what information do we have and what can we solve for right now. Okay, so we've gotten some more info. So now, remember, anytime you have 2 out of the 3 pieces of information, we can use Ohm's law. So we're going to do that again here. So for V1, we can solve for it because we know I1 and R1. V is equal to I times R. So if we do 0.1 times 100, this is 10 volts. And we're going to do exactly the same thing with V4. It's going to be I 0.1 times 150, which is 15 volts. Okay, so we know that this is actually a great piece of information. We can actually solve for V2 and V3 with this information. So we know that this is 10 volts, this is 15 volts. So remember, because these two are in parallel, they have to be the same number. And these three numbers need to add up to 100. So if we do 100 minus 10 minus 15, that's going to give us our V2 and V3 voltage. Because we know 10 plus 75 plus 15 equals 100. So it doesn't matter if it's in this loop or in this loop, it should add up to 100 for both paths. And now because we have R and V, we can solve for I by doing V over R for both of those. They're going to have the same I. So 75 divided by 1500 is 0.05 amps. And actually this is going to be the same thing because it's the same number. Now this should make sense. Because these are parallel, they should add up to what the total current was. 0.05 plus 0.05 is 0.1 amps. Okay, these are going to be very difficult if you have not done your series homework or your parallel homework. I'm going to tell you right now. You have to have a good understanding of the relationships before you can tackle these. Okay, we're going to try another one. Okay, so here we're only solving for RT. To be honest, I find that resistance is the one that is the most difficult to understand how to do. So that's why we're going to focus on that here. So we're going to number these off, okay? So this is R1. Let's make this R2. This is R3, R4, R5, R6, and R7. I went the opposite way, but that's fine. Okay, so let's recognize what is what. So here, R1, R5, 6, and 7 are in series with each other, correct? They're all on the same one pathway line. So I'll put a little S. So series, 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 series. Okay. However, here, when we have the fork in the road, there are two paths. So we have the blue path and the green path. So the blue path and green path are parallel to each other. Okay, they're parallel to each other. However, R3 and R4 are in series together. They're like their own, this is like their own little mini series circuit. Okay, so we have 1, 5, 6, and 7 that are in the big series circuit. The blue path and the green path are parallel to each other. But on the green path, we have two loads that are in series with one another. So 3 and 4 are not in series with 5, 6, 7, and 1. They are in series with only each other. Okay, we're going to continue this in the next part.